Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here that we are going to discuss today it is the paramagnetic behavior of the transition elements. That what is the main paramagnetic behavior? This is the new term to you guys. Basically, first of all, we will discuss about the transition elements, all the elements that are belonging to D and F blocks in the periodic table. These are called as the transition elements of the periodic table, as they have their valence electrons in the d subshell, or as well as they have their electrons in the f subshell. So that's why they are called as F and D block elements. There are its two forms. The number one, we have outer transition elements, and we have the second one which is called as the inner transition elements. Now they all have this specific type of behavior which is called as paramagnetic behavior. Now paramagnetism is basically, this is a simple picture in which we have the paramagnetic behavior in the absence of field, magnetic field, but when there is a magnetic field. So paramagnetic behavior is basically the attraction towards the magnet. When there is the presence of magnetic field, then that metal is just attracted toward this because its electrons just align themselves according to the field and they are just attracted towards that field. This behavior is called as paramagnetism, and in this paramagnetism you can see that all the alignment is like this, that it is moving from one to the other direction. Now the paramagnetic behavior, it is the reverse, or it is the inverse of the second behavior which is called as the diamagnetic behavior. Here, diamagnetic behavior and paramagnetic behavior of the substances, these two terms are opposite. Now, here we have paramagnetic. If we talk about the s orbital and the p orbitals, the s orbitals are fully filled, and in the p orbitals, the atoms have unpaired electrons. And when an atom has an unpaired electron, then they are attracted towards the magnetic field. This behavior it is called as paramagnetic behavior. But on the other hand, when we talk about the diamagnetic behavior, here the s orbital is fully filled. Likewise, the p orbital it is also completely filled. So they have all paired electrons and they are repelled by the magnetic field. This behavior is called as diamagnetic behavior. Likewise, here we are going to discuss the paramagnetic behavior of transition elements, as the transition elements possesses the d orbitals electrons, and these electrons are also unpaired. And when unpaired electrons are present in the valence shell of an atom, then it will be attracted towards the magnetic field. And when it is attracted towards this behavior it is called as the paramagnetic behavior of that substance. Likewise, a lot of substances or a lot of transition elements are here that show the paramagnetic behavior towards the magnet. So basically paramagnetic behavior is just because of one thing, which is the presence of unpaired electrons in an atom. It can be present in an atom, it can be present in a molecule, as well as it can be present in the ion. So it depends upon what type of substance is present over there, and there is every time a magnetic moment that is associated with the electrons. These electrons are known as the spinning electrons, and these electrons are present in the unpaired form like this. And when there is a paired electron in an orbital, then the magnetic moments are just cancelled the effect of one another, and when they just cancel the effect of one another, then these substances just become the diamagnetic in nature. Likewise, if we talk about simple example of the paramagnetic behavior of the strongest substance, which is the iron, when it is present in the plus 3 state, and that of manganese that is in plus 2 oxidation state. Let's have an example for the paramagnetic behavior of the substances, which is their graphical representation. Here we have the atomic number along x-axis, and here we have the observed paramagnetic movement along y-axis. So this is the x-axis atomic number. Likewise, if we talk about the scandium, its paramagnetic behavior is lowest, but with the gradual increase in the oxidation state, the highest is that of iron, manganese, and iron when it is plus 2 and plus 3 state. Likewise, here we have plus 2, iron plus 3, and here we have manganese in the plus 3 state. But after that, when we reach at cobalt, nickel, copper, and zinc, there is a decrease in their paramagnetic behavior. What does mean that? Because here the d orbitals of the zinc are completely filled. So that's why its paramagnetic behavior is not present, because if any substance having filled d orbitals or having no unpaired electron in its subshells, then it will not have paramagnetic behavior. But on the other hand, these substances have unpaired electrons in their d subshells, so that's why these are showing the paramagnetic behavior, that they are attracted towards the magnet, or they show the magnetic movement. So this is a simple overview about this topic. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section. And the next topic that we will discuss, it is the oxidation states of transition elements along with their variation. And we will discuss how do the oxidation states variate of all the transition elements from positive 1 to positive 7. And for that time, you guys keep learning and have a good day.